we are asked to find vertical asymptotes and domain. So vertical asymptotes and domain are very similar to each other. The first step you should do is see if you can factor and cancel. Now for this part A, 2 plus x will not factor. There's no common factor and it's x to the first. And 5x minus 6 also will not factor for the same reasons. So to find the domain, you take the denominator and set it not equal to 0. And that's because we can never divide by 0. Now we just solve this by adding 6 to both sides and dividing by 5. We get the domain as all numbers except for 6/5. Now what about vertical asymptotes? Vertical asymptotes are similar. We take the reduced form of the rational expression, which again this one did not cancel, so it was already reduced. Take the denominator and set it equal to 0. Now the algebra is going to be exactly the same as we did here, so we don't need to go through it again. It's going to be now x equal 6/5. I do want to stress that these are vertical lines, so it should be x equal, not just a number 6/5. But the line x equal 6/5. Domain should have a not equal to. Vertical asymptote should have equal to. Alright, so then what about part B here? So again, the first step is we want to see if we can factor and cancel. Now this numerator is a difference of two terms, so our hope would be maybe it's a difference of squares. Definitely can square x to get x squared, but there's no whole number that I can square to get 5. So I'm going to have to leave this as 5 minus x squared. Denominator is a trinomial, so if it factors, it's a binomial times a binomial. Only way to multiply to get 2x squared is a 2x and an x. Only way to get to multiply to get 3 is 3 times 1, but we got to be careful about the placement in order to get the correct middle term. We need a 3 here, a 1 here, signs are different, and the bigger portion needs to be plus. So that factors as 2x minus 1x plus 3. And of course you could FOIL it back out to check. Now again, nothing reduces. So with my domain, I take my denominator not equal to 0. And since I've already factored, it's easier, I get the first step done, if I just take the factored denominator not equal to 0. Now I have a product. I don't want that to be 0. The only way that can happen is if each one of these individually is also not 0. These are linear. So this first one we get x cannot be 1/2. And the second one we get x cannot be -3. Those are the two values that must be thrown out of the domain. Now for vertical asymptotes, again it's very similar to the domain. I take the reduced form, which again this was already in reduced form, and this time I set the denominator equal to 0. Now once again, since it was the exact same denominator in both the reduced and original form, my domain and vertical asymptotes are going to be very similar, except my vertical asymptotes will be x equal 1/2, x equal -3. Now what about this last one? Here of course we're going to see something a little bit different. Start the same way, factor. Numerator is a trinomial. This is an easier one because it's an x and an x to get the x squared. So I just need two numbers multiply to get 20, subtract to get 1. That of course is 4 and 5. Signs are different, larger ones minus. So x minus 4x, or sorry, x plus 4x minus 5. Denominator is a difference of two squares, and that factors as x minus 4x plus 4. So this one will reduce because the x plus 4's cancel. And we're left with x minus 5 over x minus 4. Now when we do the domain, we have to go back to the original denominator. Again, it's easier to look at it in a factored form, but before you cancel for the domain. So here, x minus 4 times x plus 4 is not 0. Those are both linear factors, and when I set each individually not equal to 0, we have to throw out 4 and -4 from the domain. Vertical asymptote is similar, but here we see more of a difference. I have to use the reduced form for the vertical asymptote. So now the only factor in my denominator is x minus 5. which I set equal to 0, and I get one and only one vertical asymptote at x equals 4. Now you're probably asking yourself, and it's a good question, what happens at negative 4? Anytime you have a factor that cancels out of your numerator and denominator, you get a hole in the graph. And that hole is going to occur at the x value of negative 4, whatever makes that factor that you've canceled 0. So, in summary, when you're comparing, domain and vertical asymptotes are very similar. For many of them, it's the same idea, except not equal to for domain, equal to for vertical asymptotes. The difference is if you cancel, and in that situation, you'll have fewer vertical asymptotes, because you can think of it as you've canceled out a vertical asymptote. And any difference in the values that you found to throw out of the domain and that you have for a vertical asymptote, there will be a hole in the graph at those x values.